Grade 12, these are the answers for your revision sheet. Number 1, carbon shows a very strong tendency to form. Of course, it has a strong tendency to form covalent bonds. Carbon is a non-metal that mostly form covalent bonds, whether with carbon or with other atoms. Okay. Number 2, how many outermost electrons does carbon atom have? Carbon atom has all in all 6 electrons, of which 2 are in the first level and then 4 are in the outermost energy level. So the answer is B. Number 3, how many single covalent bonds can a carbon atom form? Single covalent bonds means a covalent bond arising from each one of the outermost electrons. So it's 4. Now the answer of number 3 is C. Number 4, when a carbon atom forms 4 covalent bonds, the bonds are directed toward the corners of tetrahedron. Tetrahedron means that the carbon is in the middle and there are 4 bonds arising all around it. Carbon atoms readily join with atoms of both other elements and carbon, as we just said. 5C. Number 6, what are 2 allotropic forms of carbon? Carbon forms allotropes like diamond and graphite, and the allotropes of carbon, they have totally different properties according to the arrangement of the carbon in them, the carbon atoms in them. Number 7, which of the following is an allotropic form of carbon? As we already said, D, diamond. 8, which statement about the hardness of diamond and graphite is correct? Of course, you know diamond, and then graphite is the lead that is used in your pencils. So diamond is very strong and graphite is very soft. The answer is B. 8, diamond is very hard and graphite is very soft. Number 9, what do all organic compounds contain? Of course, all organic compounds contain carbon. Number 10, which of the following is an atom or a group of atoms responsible for the specific properties of an organic compound? Each of the organic compounds, they contain a group of atoms that are called the functional groups. These functional groups are going to determine the classification and the properties of this specific compound. So number 10, the answer is functional group D. 11, what is a functional group? So the functional group is a group of atoms that help determine the properties of an organic compound. C. Number 12, what does a functional group determine? It is going to determine, we're in number 12. What does a functional group is going to determine? It's going to determine, as we said, the properties and the classification of the compound. So number 12, D. 13, the properties of a functional group help to systemically classify it. Why are the functional groups important? Because of 2 things. First of all, they help to systemically classify the compounds, and the reaction of a compound involves the bonds with a functional group. So the answer is C, both A and B. Number 14, all organic compounds containing the same functional group are classified together. B. 15, which of the following is the functional group in alcohols? The functional group in all of the alcohols is the OH group. Okay, so it's B. 16, the name of a compound with a functional OH, as we just mentioned, OH is the functional group that forms alcohols. So what is the suffix in the case of a group containing the functional in a compound containing the functional group OH? It's OL. 17, what are alkanes called when atoms of fluorine, chlorine, bromine, or iodine are substituted for hydrogen atoms? First of all, whenever fluorine, chlorine, bromine, or iodine are substituting hydrogen atoms, of course, these 4 elements are halogens. So whenever they are replacing hydrogen atoms, we call them alkyl halides. Halides because it's coming from the word halogens. So now they are alkyl halides instead of just being alkanes. 18. How is the functional group in alkyl halides often written? We just put a dash and the name of the group. Okay, so the answer is C. Number 19. In the figure above, we have to look at the figure above here. To what class does the organic compound belong? We're going to look at the functional group that are added. The functional group are all OH group. We said that OH group belong to alcohols. So 19A. 20. Name the compound in the figure above. We need to name the compound. To name the compound, we're going to look at the functional groups and we're going to mention to which carbon atoms they are attached. So the name is going to be 1, 2, 3 propane triol. 1, 2, and 3 because this is where they're added, and it used to be propane but OH replaced the hydrogen here, so it's propane triol. We go to number 21. So here in number 21, in the figure above, name the compound in the diagram D. We go to the compound in the diagram D, and we're going to find that bromine has replaced the hydrogen here. So how are we going to name it? Here it is going to be bromopropene. But which one of the bromopropene? It is the second one, because the bromine is attached to the second one. This used to be propene, but now bromine replaced hydrogen, so it's bromopropene. Then, in the figure above, name the compound in diagram B. We go to the compound in the diagram B, and the name will be 1,3-butadiene. Why do we call it 1,3-butadiene? Because we have one group attached to the first carbon and then one group attached to the second carbon, which are the CH2. So we have 1,3-butadiene. Number 23. In the figure above, name the compound in diagram A. We're going to go back to diagram A. This is ethene. As we said, ethene contains two carbon atoms that are attached by a double bond, and then the carbon atoms are attached to hydrogen bonds by single bonds. So it's C2H4 or ethene. It's the one of the simplest alkenes. By the way, the 1,3-butadiene is used in the manufacturing of synthetic rubber. Okay. Number 24. Name the polymer in the process used to make vulcanized rubber by heating rubber and sulfur. So how do the polymers, they are formed of one or two monomers that are combined together, and some of them they are used to make vulcanized rubber. Okay, so the answer of number 24 is rubber, because this is what we add, this is what we use in order to form vulcanized rubber. 25. Which are large molecules made of many small units joined by organic reactions? They're polymers. Okay, polymers are made of one or two or three monomers added together. So they're polymers. So number 26. Two different monomers joined to each other, they are going to form, as we just said, a polymer. Number 27. Macromolecules found in living things are which of the following? Can they be synthetic or natural polymers? Of course, as long as they are present in living things, they are natural polymers. What polymer is formed by a chain addition reaction? What polymer is formed by a chain addition reaction between monomers that have a double bond? Of course, they are addition polymers. Addition polymers are formed by the addition of many monomers together and monomers together that have a double bond. They are called addition polymers. We're going to solve the completion reaction in the next video.